Welcome back to Algebra 1. We've been talking about solving equations. And now for Chapter 3, Section 5, we want to talk about the dreaded word problems. Now, word problems aren't bad if you have a strategy for attacking them. We're going to actually pick up the last problem in Section 3.4 because it's a good classic algebra problem. So whenever you do a problem, whether it's for algebra, chemistry, physics, first I want you to list your knowns and unknowns, think of a formula, and solve it. That's pretty much how you do all of these problems. So our problem right here is a classic Algebra 1 problem. You're joining a video rental club. These books are out of date when they're published, so it's just kind of funny because they always have really out of date problems, but we're very concerned about joining video rental clubs. Okay, and you can go to the video shop and rent videos for $8 each, or you could join a club where they're only $3, but you have to pay $50 a year membership fee. So when is it worth it? How many times would you have to rent for it to be worth it to pay that $50 and join the club? Or are you going to rent that many in the year? I used to always figure this out. We used to join the Dallas City pool, and I always would think, okay, we need to go 7 times to get our money's worth. And once we hit that 8th time, we were going for free. I loved it. All right, so these two, how you do a problem like this where you have two situations, you set them equal and solve for x. So on one side, you've got 8 times every time you rent it is how much it costs, $8 times however many times you rent. And in the other situation, you have $3 times however many times you rent it, plus a $50 membership fee. When is it going to be worth it? When is it going to be equal is what we're really looking at. And there's a bunch of algebra problems you do exactly this way. You think of 2 things that are equal, set them equal, solve for x. So now we just do it our regular way. Our y isn't ugly, x's are on both sides. We got to gather up our terms and get them together. How we move things is doing the opposite. And the opposite of this plus 3x is minus 3x. Well, we mark those out. What we do to one side, we do to the other. And 8x minus 3x is 5x equals 50. Why is x not alone? It's being multiplied by 5. What's the opposite? Divide by 5. What I do to one side, I do to the other. Those cancel out, so x equals 10. If I rent 10 movies a year, I've broken even. Once I'm to 11, I'm getting them for a better deal. Okay, here's our next problem. I'm going to erase. The next one is you are going to a high school called East. Made me think of East Paulding High School right here. In this high school, they have 579 kids taking Spanish, and this is growing at 30 kids per year. They have 217 taking French, and they're losing 2 kids every year. The question is, when will they have 3 times as many people taking Spanish as French at this rate? And x, the thing I'm trying to find is the number of years. When? Okay, so this is in section 3.5. Well, I'm skipping the one about the yearbook. There's an error in that one. So in your book, my book, all of them, they have an error in that problem, so just skip it. All right, so once again, we're looking to set things equal because we want to know when it's going to be the same. And so we got 579 Spanish students plus 30 each year, and we don't know how many years it's going to be, equals our French kids, 217, and they're losing 2 a year, and we need it to be equal when it's 3 times as much, so we're going to do it times 3. And it's 2 per year, so we have to have an x on that side too. Okay, I am going to erase my problem. Now, why is this ugly? First of all, those parentheses, so I need to distribute that. Let's cheat and see what 3 times 217 is, so I don't have to do it. 651 minus 6x equals 579 plus 30x. Now, we can gather up our terms. I'm going to do plus 6x to both sides to get all the x's together. Bring down what you didn't mess with. 36x equals 651 minus 579. What's the opposite of plus? We're going to work from what's outside in. And the opposite of this positive or plus 579 is minus 579. What I do to one side, I do to the other. Those cancel out. So 36x equals maybe 90. Let's see what it is without 72. And then y is x not alone. It's being multiplied by 36. So the opposite is divide by 36. Those cancel out. X equals 2. In 2 years, they will have 3 times as many people taking Spanish than French. Hire another Spanish teacher. Tell that French teacher she's going to have to teach something else. Like maybe she could teach Spanish. Maybe she'll just teach more. Maybe she's multilingual. All right, the last word problem we're going to look at is one where we have a gazelle and a cheetah. Okay, and the cheetah is faster. Its velocity is faster. But it gets tired after 20 seconds and quits. So how far does the gazelle have to be away from the cheetah to be able to get away? This always makes me think of Dave Ramsey. He always says you're going to be like a gazelle and get rid of all your debt. You're not going to be like a cheetah and quit. You got to keep paying on those credit cards. Dave Ramsey. All right. He's a financial advisor on the radio that we met once. He came and spoke at our church. Okay, but anyway, back to this. It's not about credit cards. All right, so if we want to know what the distance is between them when it's on the very edge of the 20 seconds, because we know if x is more than that, then the gazelle will get away. If it's less than that, then the gazelle will get eaten. And right at the time, it's probably a toss-up. Probably the gazelle would die. But, okay, so our x is the distance to the cheetah. Okay, so we need to do 73. It's feet per second. We have 20 seconds. So times the gazelle speed times the cheetah. And then the cheetah's speed is 88 times 20, and we need to know where the gazelle needs to be far enough away from all of this. So plus some distance, then we'll be able to figure out how far that distance is when right at 20 seconds. Okay, so first we need to straighten this out, because what's kind of making this ugly are these parentheses on both sides, these multiplication. Okay, and do we have them written there? Nope, we'll have to do it on the calculator. So 73 times 20 equals 1460. And then 88 times 20 equals 1760. Y is x not alone, it's got a plus 1460, so we do the opposite, we minus 1460. And so x equals 300. If the gazelle is further than 300 feet away, it will get away. So x needs to be greater than, I would say, 300, not equal to. Because if it's equal to, I don't know. I think probably that cheetah's going to win. He's got claws and fangs and all that. All right, so those are word problems. You got to list your knowns and unknowns. And with a lot of times you can figure out how to set things equal and solve for x. Here's another secret about word problems. There are not infinite number of word problems in the world in algebra. They just pick certain classic problems. And once you learn those classic ones, you know how to do it. So it's not like there's just an infinite variety of problems that you're going to get in an algebra class, an SAT, an ACT, a college entrance exam. There's only certain ones. The video rental club, you know, things where you can set 2 things equal and solve for x. Always look and see if you can do that, because if it is, it's pretty easy. All right, math is fun.